presentation is going, our first presentation is going to be Zach Moss, the Save Our Streams coordinator with the Izaak Walton League of America. Based in his home state of Iowa, Zach will be working with stream monitors, volunteer stream monitors in the Midwest. He has a bachelor's degree in environmental science from the Central College of Iowa and a master's degree in natural resources from the University of Idaho. And I will let Zach take it from here.
Awesome, thank you so much. Thanks everybody for joining. I know this is kind of a crazy time, but I'm really happy we can all adapt and find our way in here to learn and collaborate together. So without further ado, I'll just get started. I'm going to talk a little bit today about the Izaak Walton League's Winter Salt Watch campaign. It's a citizen science project that the Izaak Walton League's coordinating on a national scale. And we have a lot of other just trying to make sure I can advance my slides here. There we go. We have several other citizen science projects that we are working with and partnering on. You can see some of them listed out here, kind of from top to bottom is the scale from least involved to most involved. So we have projects like Stream Selfie, where it's just going out and taking a picture of a stream and answering a couple of questions about if you saw any garbage along the stream and if it flows all year long or not, and why that stream matters to you. Really simple for kids, and then all the way down to Virginia Save Our Streams and Save Our Streams, which consists of a training and quality assurance protocols, and that's mostly macroinvertebrate monitoring. But I'll be focusing this talk on Winter Salt Watch, their second from the top. And you see me looking back and forth. I am working with my notes on this screen and the presentation on this screen, so forgive me if I'm not looking at the computer all the time. But if you're not familiar with the Izaak Walton League, it's a national nonprofit environmental group. Our mission is to conserve and restore and promote the sustainable use and enjoyment of natural resources that consists of soil, air, woods, waters, and wildlife. Right now, the past few years, we've been focusing a lot on water. So you might, if you're familiar with the Izaak Walton League locally, your local chapter might be more of a shooting range, or maybe they work on youth engagement. The local chapters all do their own projects. The national mission is just the conservation, restoration, enjoyment of natural resources in general. So Salt Watch started 2 seasons ago. We're in our 3rd season, or just finishing up our 3rd season right now. This is a picture outside of our national headquarters in Gaithersburg, Maryland. And what you see on the road here is road salt that somehow got spilled and dumped on this busy road. It was too dangerous for anybody to go out and clean up themselves. It's a busy road, people are driving across it. But there's clearly a chemical issue going on here, because this, I don't know how well you can see it, but kind of in the bottom left, this salt is basically right on top of a storm drain. So it's going straight into a local creek. And so they started thinking, you know, if this is an issue here, then it's probably an issue in other places around the country. So what can we do about it as the Izaak Walton League? What can we do to encourage responsible use of road salt and other chloride sources? And how can we monitor for that in our local streams? And so that birthed the first season of Winter Salt Watch in 2017-18. And we didn't have a ton of participation that year just because it was so new. But last season and this current season have been pretty successful, I think. So this is an education and awareness and advocacy campaign. We don't do trainings and don't do any really strict quality assurance issue or protocols. But the main goal is to just educate the public, raise awareness that even though it's wintertime, we don't necessarily always think about water quality in the wintertime. But the water is oftentimes still flowing under the ice in our streams and rivers. And a watershed basic properties still apply. So, just the general idea of what happens to the land happens to the water. And so that includes all the chloride and road salt that's spread across our parking lots, sidewalks, roads, and highways during the wintertime. We don't always think about it flowing into our streams during the wintertime, but its purpose is to melt the ice and the snow into water, which then goes directly into storm drains and into our waterways. And so then, in addition to the education piece of it, just letting people know what's going on is an advocacy piece. So we're encouraging people to learn about this issue, go out and monitor, figure out what's going on locally, and then after that, take steps to advocate for smarter application, calibrating tools, applying salt at the right time, working with private landscaping and snow removal contractors and property owners, and just trying to do what they can locally from a grassroots level. And I believe some of the people after me will be talking a little bit more in depth about some of the more scientific and academic impacts of road salt and chloride in water. But this is kind of just the basics that we use in our Salt Watch campaign. We typically say that a freshwater stream should have fresh water. Seems kind of obvious, but it's oftentimes not the case. So we aim for less than 100 parts per million chloride in a stream. Usually you can find baseline levels between 10 to 20 to 30, sometimes up towards 50, but we generally just say if it's under 100, it's considered typical by our measures. But 230 plus parts per million we consider concerning as a chronic threat to, or chronic exposure to aquatic life. And so you can see here some of the different organisms that can be affected. But like I said, I think other people after me will talk a little bit more, but the main issue that we're trying to confront is that the water is getting too salty, and it can affect aquatic life as well as human health. So if you were to go to IWLA.org/saltwatch, you could order a Saltwatch kit for free, which is how we spread the campaign around the country. And these are all packaged at our national office. I work remotely here in Iowa, so I get out of all that, the brunt of that hard work of packaging up the hundreds or 1,000 kits this year. I have some very hardworking coworkers out in our headquarters in Maryland that package all these up every year. And so if you were to order a kit, it'd come with, there's a typo on here, it actually comes with 4 chloride test strips, not 5. But those test strips are sealed in a, I don't know if you guys can see this well on your computers, but it comes in a little plastic bag, and you open the plastic bag and it comes with the 4 chloride test strips as well as a silica gel packet. So I'll just hold these up here. Here's just what this chloride test strip looks like. It's really small, easy to mail, thin. So we just stick it in an envelope and send it out. And it comes in that plastic bag with the silica gel to help keep it dry so that the strips don't get wet and your results don't get ruined before you even get your kit. It also comes with a postcard of how to use your strips as well as how to submit your data. And you can kind of see in the bottom right of that picture on the slide is a picture of the postcard that has your scale of results. So each batch of these Hawk chloride test strips that we use uses a different scale, just depending on which bottle or which batch you're getting. So each postcard is specific to the strips that you're getting in the mail. And you can see at the bottom of this slide, last year was our first full year, the 2018-19 year, and we sent out about 500 kits. This year we ramped that up even more and sent out about 1,000. So we are steadily growing and spreading the word. So this is, like I mentioned, it's a citizen science project. You don't need to have any prior experience with natural science or chemical monitoring or stream monitoring. It's meant to just be inclusive to anybody. You can see here we have school classes, we have kids doing it, retired people, as well as students, watershed groups, just concerned citizens. And then we also, like I mentioned on that second slide, we have several other several other citizen science water quality monitoring projects. And so this is something to keep them engaged during the winter time when they might not always be out, might not have a reason to get out and do the monitoring, but they still want a reason to get outside. So Salt Watch is just a simple test that only takes a few minutes, and they can get outside and get instant results and share it instantly. Oops. So we encourage people to monitor before a winter storm or in the fall before it starts snowing. So we start our season around October and encourage people to try to get their first reading before it starts snowing, so we can kind of see what the baseline is in the stream that they're measuring or that they're monitoring, and kind of see what the normal levels would be. Then we also encourage monitoring after salt has been applied to the roads, and then after the winter snowstorm. So some of that snow and ice is going to melt when the salt is applied, and that's going to then go into the storm drains, and that'll should see a spike in chloride levels after that. And then in addition, in the springtime, or if you have winter rains, monitoring after a rain event, because oftentimes I'm sure many of you have seen walking across a parking lot or any concrete or pavement when too much salt has been applied and it's still sitting out even though it's a dry, warm day. So then it rains on top of that, and that just gets washed into storm drains and carried in by the rain. So we encourage people to do all these different, monitor at all these different times, so we can track kind of how the salt is affecting the stream at different times. And so what you see here is a screenshot of the Water Reporter app, which is what we use to submit and then analyze the results, or not analyze, but to take our results in for analysis. So Water Reporter is just a free smartphone app, and you can see this person here has their postcard. So that postcard has their scale specific to their batch of chloride test strips, and you stick your test strip in a little cup or a dish or something, leave it in for a few minutes till it's completed, and then they can hold it up and snap a picture of it. So they don't have to do any work beyond that. They put the strip in the water, wait for your results to be completed, and then send us a picture of this with a geolocation of where you did your monitoring. And then we can then convert the Quantab units, which is what the strips measure, into parts per million of chloride. So we go into Water Reporter, which is it's kind of a social media app designed for watershed groups and watershed initiatives. And our volunteers submit their results and tag it with the hashtag SaltWatch. So then we can easily just go in and search hashtag SaltWatch, and we can see all the different SaltWatch submissions. And we pull those out for our own analysis and for sharing with our volunteers. So this is an example of another postcard. It comes with 2 postcards in your kit. And it gives you just simple step-by-step instructions on how to get started and how to use your Water Reporter app to participate. You can see here in this middle box, all you gotta do is open the app, start a post, add your photo that you just took, and tag it with SaltWatch, and that's all that people have to do. So the test itself takes anywhere from 5 to 7 minutes. When I do it, I just scoop the water out of the stream, stick my test strip in, and then get back in my car and warm up while it does its thing and gets our results for us. So you only have to be outside long enough to get your water sample, and then you can get back into the warmth. And I think that's really appealing to people. So on the Water Reporter app, we obviously can submit the chloride monitoring results, but we also encourage people, if they're seeing big piles of road salt out there or areas that have just been way over applied, that they can share their pictures of that there as well, just to help raise awareness of what's going on and what it looks like if road salt application is irregular. So obviously some of these pictures, like this one in the top left, that's a lot more road salt than you would need to melt a little bit of ice or snow on a road. And you can see this guy in the bottom middle is actually a former Clean Water Fellow with the Izaak Walton League, and he went out to the parking lot and scooped up excess salt after the winter storm had passed and put it in the bucket for reuse. So that's another thing that we aim to do, is just let people know what can be done to encourage responsible use and what they can do locally. So we've had our issues. Not every report is great. Some of them get cropped funny. You can see in the picture on the left, they submitted their results postcard, but they didn't even get their strip in the photo because the Water Reporter app crops it to be square. So sometimes people take a landscape photo and it crops out the edges. So we can't always use every result. And then I don't know how well you can see, but that middle one, it's expired. And so I don't know what's going on, but that's not what the test strip is made to look like. And so there must have been some issue along the way. Maybe they were using an old kit from last year or something they had in their closet. So that just is another reason why it's important to have our staff go through and quality assure, and pull that data out off of the Water Reporter app.
We have one quick question. What percent of results were valid or were you able to use?
You know, I don't know that off the top of my head. One of my coworkers is the one who pulls all the data off the app and analyzes it. So unfortunately, I don't know that off the top of my head. And also I've been seeing some questions pop up, and I saw one that asked how much the kits cost, and these are free. It's just comes with 4 chloride test strips and a couple postcards. So it's relatively inexpensive for us, and we have grants that help fund that. So it doesn't cost anything for the monitors themselves.
And are they only focused on lakes, or are they also focused on streams?
Yeah, we aim, you know, our kind of bigger project that we focus on at the Izaak Walton League is Save Our Streams, which is more aiming towards streams clearly. But you can also do this in lakes. You can do this in larger rivers. So salt watch is meant to be used anywhere. So, and then this is what successful submissions look like, as well as a picture of somebody's dog down in the bottom. So successful submissions, you can see this second one over on the top left. You can see that white peak rising, and we just measure where the end of the white peak is, and then we can look over and convert those quantab units into parts per million. And my coworker that I mentioned is the one who goes through and pulls all those off the apps. Yes, volunteers can sample any waterway that they wish. So we have one staff person that goes through and pulls all those results off and and then puts them on an interactive map for our volunteers to look at and see what's going on around them. So this is our first full year, 2018 and 19. We got a lot of high chloride readings, probably not surprisingly, in the metropolitan areas that were participating. So this is in the DC area, which is near our national headquarters. And the numbers on the map are how many submissions how many reports were submitted. And then the color is the chloride readings that were found. So this is DC, which is one of our high traffic areas for the Salt Watch program. And then this is also Philadelphia, which got a lot of attention as well. And an interesting thing about Philadelphia is a lot of the participation we got in that area was mostly just through word of mouth. Somebody with River Network heard about it, talking with one of our staff members, and then spread that on to other watershed groups in the Philadelphia area, and got a lot of attention, a lot of traction in the local watershed groups. And this is just zooming out from our first full season, first full season to all our different participants across the country. And fast forwarding, going back actually, our first season, we just broke it down by watershed. And so you couldn't see the individual sites or results. But then this past season, we used ArcGIS Online to give us point data. And it's clustered so that you can see some of the bigger circles are areas that had the most participation. And then the color coding is the results that people are finding. So if you were to zoom in on this, For example, zoom into Wisconsin, you can see around Green Bay, there's a green submission, which means that there's healthy chloride levels, and then there were some red submissions. And then if you look over in the Minneapolis area, you can see a little bit bigger circle, meaning that we had a lot of participation in that area. So you can zoom in and see those individual sites and click on these dots and see the results. So I've got a few minutes left. So a question that often gets asked with citizen science is, what are we doing this for? What next? And so we encourage people to take local action. These are all available on our website. We have resources to support our salt watchers, but what we're trying to do is just encourage local action and advocacy based on the empirical data that they're gathering themselves. And so, you can share the news with friends, you can report to a local watershed entity, whatever that is in your area. Here in Iowa, we have watershed management authorities. You can contact your city, your county DOT, or whoever's responsible for applying road salt in that area. And as well as, contact media and share best practices with landowners and HOAs and property managers and things like that. And so this is just one example of one of our salt watchers, or one of our salt watch groups, the Muddy Branch Alliance over in DC. They snapped this picture, and they're educating their base, their followers about why salt is unhealthy. And then they also, you can see underlined in red, they reported it to the county and got it picked up. So just educating people that, if you see a big pile of salt on the road, that's not normal. And there are people that you can contact to help take care of things like that. We also got some press coverage across the country. This is an article from a Great Lakes area news publication called Outdoor News. And this is from Berks County, Pennsylvania, talking about salt watch and educating their readers about why road salts and chloride can affect their water. And we're also trying to, as it gains traction and gets more attention across the country, trying to partner up with other groups and agencies to, just go beyond this one kit with 4 strips that individuals can order, and kind of do a little bit more organized monitoring with a purpose and whatever's relevant to them. So Virginia Department of Environmental Quality has a salt management strategy they're working with us on just some education advocacy parts. Coon Creek Watershed up in Minnesota, they've been doing a lot of monitoring, organizing volunteers and monitoring chloride in their area, as well as we're going to start working with the Minnesota Pollution Control Agency to monitor more for chloride in terms of area, so more places, and then also time. So monitoring during the summer and getting more baseline readings in the summertime. This is just an example of the Virginia Salt Application Management Strategy resources that they're putting out. And I saw a bunch of questions popping up, and so that's the end of my presentation. We can answer some questions here.
Thanks, Zach.
Yeah.
One of the questions I saw that I think was the next in line was, are you using these results to guide local or statewide policies, e.g. funding smart salt training programs for private road salt applicators?
We, on the national level, aren't doing a ton of stuff like that, just because we are a national organization. But like I mentioned on one of those last few slides, we're trying to partner with some of these more local and grassroots organizations as well as agencies to do exactly that. So that's kind of our goal, is that people can see this and pick it up and realize that there's an issue going on. But if you go to our website, we do have resources for people to learn more, and also how to get involved and how to advocate.
And then are there instructions on how to take photos so it's a successful submission?
Yeah, that was actually something that we just learned this past season, that was kind of a big issue with some people. And so we're learning all the time. But yeah, we stay in touch with people a lot through social media and newsletters. And so all of our people who order a Salt Watch kit get an email once a month during the Salt Watch season. So stuff like that is included in our newsletters, yeah.
Awesome. And then can volunteers sample any waterway that they wish?
Yeah, so we have people that monitor little tiny streams that are, you know, just above your ankle. We have people that monitor big rivers, lakes as well. So lakes are kind of a central repository for salt, obviously, or any pollutant. And so monitoring for lakes would be good as well.
And then is your data available for anyone to download?
You know, I don't think it's available for download right now, but if you're interested in getting the results from us, you can just email me or email sos@iwla.org, and we can get that over to you if you're interested in getting that.
And then any suggestions for gravel road dust control instead of using salt?
You know, I don't know a ton about that personally. I know that it can be a contributing factor, but I don't know a whole lot about dust control. We've been focusing mostly on salt application for snow control.
Well, thank you again, Zach. And then
thank you, everybody.
Yeah. Now we'll transition into our next presenter, Linnea Rock. She'll be presenting on increasing salinity in Wisconsin's lakes and rivers. Linnea is a first-year graduate student working under Dr. Hillary Dugan at the UW Center for Limnology. Her research is focused on chloride contamination in freshwater, specifically looking at lakes and streams in the Madison area to determine their current and future conditions. Welcome, Linnea. Hopefully you can take control of the screen as well.
Linnea, once you've touched the screen once with your cursor, all you need to do from there is use up and down arrows or page up, page down.
Okay, I think I got it. Are you able to hear me now?
Yes, we can.
Okay, thank you. All right, well, good morning, everybody. My name's Linnea Rock. I'm going to be sharing some broad information today about chloride in Wisconsin's lakes and streams. And then I'm going to show you some of the trends that I've been seeing in some of my research sites this past winter. So before I get started, I just want to say thank you to everyone for being here virtually today, and thank you to our moderators. It's definitely not the Lakes Convention that we all hoped for, but I hope you at least enjoy this presentation and maybe you will learn something. So this figure shows salt use in Minnesota. The bars represent how much chloride enters the environment from various uses, which are listed on the x-axis. We do not have this data yet for Wisconsin, but we can assume it is approximately similar, and at least the trends are the same to Wisconsin. By and far, road salt is the biggest contender for salt use. There are definitely other sources like agriculture and water softeners, but today I'm focusing mostly on road salt. So when I say chloride, I mean chloride from road salt. So what's the big deal with chloride? Of all the water quality issues in the world and in Wisconsin, which there are many, why do I want to study chloride? Well, it's a very present issue. It's not a new problem. There has been widespread road salt use in Wisconsin since the 1950s. And not long after that, it became a topic of interest. But in the past decade, it has become a much more popular issue. And we are starting to see the impacts to freshwater a lot more. We also live in an area with cold winters and a lot of precipitation, meaning there's a lot of road salt use. This issue also has a lot of public interest. People use road salt on their driveways and sidewalks. People see road salt being spread on parking lots and on roads. It makes the news fairly frequently for its toxic problems it's causing to streams and lakes. And many people care about this issue and want to know how to prevent their salt use from causing harm. Another reason why I enjoy studying chloride is because there's a lot of hope for this issue. there is potential to reverse the problems and decrease the amount of chloride in our lakes and streams. It will take a lot of buy-in from the public and from the government and potentially some big policy changes. So the more research and facts we can share about this issue, the more likely a positive shift will occur. All right, here are a couple photos, and you may have seen similar things in your own community during Wisconsin winter. So in the photograph on the left, there is a red truck dumping plowed snow, which is full of road salt, onto a huge pile of plowed snow. There is a marsh directly next to the parking lot that is holding this snow pile, and that marsh can experience chloride concentrations over 10,000 milligrams per liter. And for reference, seawater has a chloride concentration of about 19,400 milligrams per liter. In the photograph on the right, you can see some massive chunks of road salt. Those are about the size of my foot. And just beyond the frame of this photo is a steep bank that leads directly to a stream. And that stream can see chloride concentrations over 1,000 milligrams per liter. So I just shared some big numbers with you. What exactly do they mean? First, I want to briefly describe the difference between chronic and acute when it comes to water impairments. So in order for something to be a chronic problem, it needs to be a persisting problem. So lakes that have chloride concentrations above those thresholds consistently are chronically impaired. And in order for something to be considered an acute problem, it needs to occur just a couple of standalone times. So the EPA recommends the thresholds listed on this slide, and they say that levels above these thresholds can be detrimental to aquatic ecosystems. The DNR guidelines listed here are what are used in Wisconsin to determine whether a water body is impaired for chloride. It's important to note that these toxicity thresholds are derived from a broad range of tests across the nation for the EPA thresholds, for example. So some really sensitive species are negatively affected by chloride concentrations far below 230 milligrams per liter, whereas some tolerant species can handle much higher concentrations. Basically, they are general guidelines, and there still is a lot to learn about how aquatic life responds to chloride. The taste threshold that you see is the chloride concentration at which most people begin to think that their water tastes salty. In the blue bubble at the top left of the screen is an example that a lot of people are able to visualize, and that is it takes only 1 teaspoon of salt to contaminate 5 gallons of fresh water. So thinking about that marsh that I showed in the previous screen, if you had a 5-gallon bucket filled with fresh water, it would take about 1 cup of salt to reach 10,000 milligrams per liter. Okay, so why do we use road salt? It's effective, it's cheap, and it's natural. It is a very effective safety management tool. It's really, really good at keeping our roads clear. That is at least above 15 degrees. Once the air temperatures dip below that, commonly used road salts are essentially ineffective. Road salt is very cheap. So it costs about $70 to $80 per ton for the state of Wisconsin to buy. $80 is pretty cheap for a ton of something if you think about it that way. But we end up spending around $40 million just on road salt each year. So while the price per ton is cheap, we could save a lot of money by reducing our road salt use. And it's natural. Salt is a natural mineral, and people tend to think that natural things are good and safe to use, but that certainly isn't always the case. For example, in quantities above those thresholds that we saw on the previous slide, salt causes a toxic environment for aquatic communities, and especially to those more sensitive species that we highly value and that we tend to look for to know that we have a healthy water body. Salt can prevent lakes from turning over, from mixing. So many lakes in Wisconsin mix twice a year in the spring and fall, right before and after ice on and off. So for most of the year, the water in deep lakes are divided into layers. And these layers have different densities, different temperatures, different nutrient makeups. And when a lake turns over, those layers break down and the water mixes. This is a very important process that distributes oxygen and essential nutrients and allows aquatic habitats to thrive. The problem with salt is that salty water is denser than fresh water. And when enough salt accumulates, it sinks to the bottom of a lake and that layer can become too dense to mix with the other layers. The news clipping up on the screen is an example of where this has happened. It's about a lake in a New York State park that has stopped mixing because of road salt runoff. And there are a few other cases where this has happened in Michigan, so that's even closer to Wisconsin. Road salt can also be very damaging. It damages soils and vegetation. It's a very corrosive material and can damage cars and infrastructure. So this figure shows the long-term trend of chloride concentrations in Wisconsin lakes and rivers over the past 6 decades. I got this data from the water quality portal. So you can clearly see that there is an increasing trend in our lakes and rivers. You can also see that sampling for chloride has become much more popular. We have a lot more data points in the past decade than ever before, which is a great thing, but the more we test for chloride, the more we are uncovering problems. So another way that we can look at this data is by looking at where these concentrations are occurring. So this map shows all the data points from that same data set for the years 1968 to 1990. Most of the sampled waters are below 10 milligrams per liter. There's a fair amount in that sort of danger zone approaching 100 milligrams per liter. And there are a few data points in the orange there that are over 100 milligrams per liter. Those were mostly collected in the mid to late 80s. So we're already starting to see a problem then. Here is a map showing the data points for the years 1990 to 2010. So a lot more lakes and rivers were tested and a lot more problems were found. And you can see that these problem areas are concentrated around the urban hubs of the state. In the past decade, we're starting to see more and more lakes and rivers exceeding 1,000 milligrams per liter, which is pretty troubling. One thing I want to point out about this slide versus the previous, there are almost 13,000 data points on this slide. In the previous slide, there were about 9,500 data points. It's a little bit misleading. It's just because in the past decade, the monitoring efforts have been focused on those problem areas. So it just looks a little misleading. It looks like there's less data, but there's actually more. So focusing on problem areas is good. In some ways, you can look at those immediate problems and try to address them, but it's also important to not neglect other areas, other lakes and streams in Wisconsin that might have levels creeping up. So I'm transitioning now to my focus area in Dane County. This figure shows increasing trends of chloride in lakes in the Yahara River chain. Up to now, there have not been any studies investigating where all the chloride is coming from geographically. And so that's one of the things I hope to illuminate through my research. Okay, so I'm going to move into a couple of examples using data that I've collected this winter. Just want to note that the amount of data I'm sharing is quite small, so we can't really draw any significant conclusions from the trends I'm showing, but it's still worth sharing because these systems are not especially unique and similar conditions exist around the state. So this map is a map of the study area for my research. And for reference, I labeled where UW and the state capital are by that little star symbol. The black dots are the river and lake sampling locations, and the circles represent stormwater flow locations. So at each of these sites, we have continuous conductivity monitoring using sensors. Conductivity measurements are affected by dissolved solids in the water, so like rock salt. And conductivity is an effective way to measure changes in salinity. At each of these sites, there are also periodic water sampling to analyze the actual chloride concentrations of the water. The red arrows on this map point out areas that are already considered impaired for chloride by the state of Wisconsin. So on the left side of the map is Pheasant Branch Creek. On the right is Starkweather Creek. And that red arrow to the north of Mendota is the Yahara River. The portion of the river that I sample is not considered impaired for chloride, but further upstream it is. All right, these figures show precipitation patterns from late December through January, which is the time that I'm going to be focusing on for the chloride concentrations I'm going to show you in the next few slides. So on the left is a figure of precipitation per day. And on the right, we see snow accumulation per day. I added a line January 10th, after which we see the majority of snow accumulation for the month. And you'll see that reference line in the other figures I show as we move on. And I just want to note that this January we had average precipitation. So the trends we are seeing this year can be generalized to trends that we might have seen before and that we'll likely see again. Okay, so first I want to show trends for that time period for the inlets to Lake Mendota. And I have tried to color code them to the colors that I use in the graphs in the next slide. So across the board, there's a general increasing trend of chloride concentrations during this time period. The figure on the left shows the two Pheasant Branch locations. And remember that Pheasant Branch is one of those rivers that is considered impaired for chloride. So the concentrations are quite high and range from 150 milligrams per liter to over 650 milligrams per liter. On the right are those rivers flowing into the north of Mendota. The Yahara River is represented by that orange line and the orange dots. And that has the highest of those three rivers, highest concentrations. And that is the river that further upstream is impaired for chloride, which could account for those levels being a bit higher there. Okay, so now I want to look at the trends for the inlets and the outlet to Lake Monona. So again, the trends are generally increasing during this time period. Starkweather Creek is shown on the right, which is considered impaired for chloride, and that has really, really high concentrations. On the left side, the inlet to Lake Monona, which is also the outlet of Lake Mendota, is represented by the blue, and the outlet of Lake Monona is represented by the orange. They're both the Yahara River. So the outlet experiences chloride concentrations about 10 to 15 milligrams per liter higher than the inlet. And there are a few reasons why this could be. Both of those locations are urban locations. But we'll look at the lakes themselves to see why the outlet of Monona might have higher concentrations of chloride. So here are the overall trends of chloride in Lake Mendota and Lake Monona for the past 2 decades. We can see that Lake Monona has a higher chloride concentrations overall, and definitely at some points it's a lot higher. Lake Monona is also less than half the size of Lake Mendota. Something that we hope to illuminate through my research is how high are these concentrations going to get? And also, how much could we reduce salt use to curb or reverse these increases in chloride concentration? So what are my next steps that I'm looking forward to? Continuing to monitor at these locations to get more information on these rivers and these lakes. I'm always looking to receive more data to gain a fuller picture of chloride in this watershed. And ultimately, we hope to show how much chloride is entering and exiting the lakes and what the future may hold. And I also hope that this study can be an example or a blueprint for future studies with similar watershed types. So there's definitely a lot of great people who have been supporting me and helping me with this research, and continue to do so. I want to give a special shout out to my research assistant, Laura, who's a senior at UW and does really amazing work with me. And thank you to Peggy, Alex, and Paul, our moderators for this session that are making sure the convention is running smoothly. And thanks to everyone for tuning in. I also just want to note that if I don't have time to get to your questions, or if you have some questions or comments that might be a little more involved, feel free to get in touch. My email and Twitter handle and website are listed on the slide here. And with that, we can open it up if we have questions.
Thanks, Linnea. We have a few questions that just popped up. The first one is the Mirror Lake study published in Lake and Reservoir Management found that the bottom water chloride concentrations in deeper lakes which stratify can be twice as high as those at the lake's surface. Is most of the chloride data available for Wisconsin from surface samples? And does Wisconsin have a data set of chloride data available from near the lake bottom?
So I'm not sure if there is a separate data set, and I don't know exactly. So the water quality portal data, I don't know exactly how many were from the surface or the bottom. We do have a mix of data. The North Temperate Lakes Long-Term Ecological Research data set through the UW CFL collects samples at a range of depths. So those concentrations I showed.
This is Paul chiming in. I'm not sure if we lost Alex. There is a question about chloride data in Wisconsin. Is that data taken from surface samples? And does Wisconsin have data available from hypolimnetic samples also?
Right. Can you still hear me? Did I cut out?
I was going to say I'm still here, and I read the question. I was assuming everyone heard me.
I can hear everyone.
Yeah, what was I saying? Oh yeah, the data points I showed for Mendota and Monona are from a range of depths, and those really, really high chloride concentrations that we saw for Lake Monona were taken from the hypolimnion, from the bottom of the lake. So it's a mix.
All right, and then another question, what methods do you use for sampling the Madison rivers and lakes, and who is doing the sampling monitoring?
I am doing the sampling and monitoring. As far as methods go, it's a basic grab sampling method. I visit those streams once a week through the winter and the spring to grab samples, and we get just a range of flows and storm conditions, and they are analyzed using ion chromatography. And the lakes, we just try to get out as much as we can, which was pretty limited this year due to unsafe ice conditions. The ice took a long time to form of the lake, and it released pretty quickly.
All right, and then we have one really quick, the last question before our next presentation. Do we have profile data for the Madison Lakes? Curious about hypolimnetic chloride samples.
Yes, this is kind of attached to that earlier question that we had. The North Temperate Lakes, LTER, does have a range of depth samples, at least for Mendota and Monona. I'm not sure who manages or who would have the data for those other set of Yahara chain lakes, but that is something that we could look into.
Awesome. Well, thank you again, Linnea.
Yeah, thanks everybody.
All right, and then our next presenter is going to be Katie Rademacher on winter road salt monitoring in the Milwaukee River Basin and actions to reduce chloride pollution at the source. Katie is Milwaukee Riverkeeper's water quality manager. Katie leads management of all citizen-based monitoring efforts by Milwaukee Riverkeeper, including baseline water quality, winter road salt, and emerging contaminant monitoring. She also manages the production of Milwaukee Riverkeeper's annual Milwaukee River Basin report card. And I'll let Katie take it from here.
Thank you. So today I'm going to talk about Milwaukee Riverkeeper's road salt monitoring program, and then also the steps our organization is taking to encourage responsible application of road salt. As Alex said, I'm the water quality manager with Milwaukee Riverkeeper, and for those that aren't familiar with us, we're a science-based advocacy organization working in the Milwaukee River Basin. And a little bit more about Milwaukee Riverkeeper. Our mission is to protect, improve, and advocate for water quality, riparian wildlife habitat, and sound land management in the Milwaukee, Menominee, and Kinnickinnick River watersheds. Milwaukee Riverkeeper is also a licensed member of Waterkeeper Alliance, which is a global coalition working towards those same goals of fishable, swimmable, and drinkable waters. And in Milwaukee Riverkeeper, we just divide our organization up into like 4 buckets, which are protect, restore, connect, and advocate. And here are just some photos of different activities. For protect, we do our baseline water quality monitoring and road salt monitoring. And here's a picture of a macroinvertebrate survey. For restore, we have an annual spring cleanup, which unfortunately we had to postpone this year. For connect, we try to get folks out to the river. Pictured here is really cool, part of our annual boat parade. So local artists decorate boats, and this one you can see our sandhill cranes, and when they do a parade down the Milwaukee River. And lastly, our organization does a lot of advocacy. So the photo there is from an open house talking about an AOC sediment project. A little bit more about the Milwaukee River Basin itself. It's located within southeastern Wisconsin, and our basin drains into Lake Michigan. The basin spans over 880 square miles and drains part of 7 counties. So those are Milwaukee, Ozaukee, Washington, Sheboygan, Waukesha, Fond du Lac, and then a little portion of Dodge County. There are over 500 miles of perennial streams, and perennial meaning they have water in them year round. And then we break our basin down into 3 major watersheds, and that in the map there you can see blue is the Milwaukee River watershed, in green is the Menominee River watershed, and then in red is the Kinnickinnick River watershed. Also, our basin is home to 1.3 million people, and the graph there in the bottom left is going to be the breakdown of land use. Milwaukee County is very urban, but the rest of the basin is a split between agricultural and also grassland and forests. All right, so I'm kind of echoing some stuff that was talked about in earlier presentations, but chloride is the key element used in traditional road de-icing methods across the northern United States. If used correctly, road salt can be a helpful safety precaution, but excessive use can have dangerous consequences to our water while not improving public safety. So the shift to road salt began in the mid-50s and began to be studied shortly after that, and chloride levels in surface water have been increasing rapidly throughout our state. So how does road salt get into our waterways? It's mainly through runoff, which is water traveling over the land surface carrying that road salt, whether it's into a storm drain like this top picture here, or directly into a river. So mainly we're focusing on the impacts of road salt to our aquatic environments, but road salt can also be damaging to vehicles and infrastructure, harmful to pets and also wildlife, and then damaging to soil. And also many plants are not salt tolerant, so that can have impacts as well. And it's important to remember that we have freshwater systems here. That's why I have the Finding Nemo sharks there in the corner. Like these are not saltwater systems. So chloride is toxic to freshwater fish and all other organisms within the stream. In these freshwater systems, as chloride in the water increases, it displaces water within the aquatic organism, leading to it to dry out or desiccate. And a familiar example to that is if you've spent time in the ocean and you come out, your skin is kind of dry. So this was highlighted earlier, but there are two types of chloride toxicity. The first is chronic toxicity, and this is an extended period of an increased level of chloride within the stream. So you can see that fish is kind of stressed out. This increased concentration may not immediately harm or kill organisms. However, it can create a very stressful environment and cause damage over time. It can stress, organisms out and they can not be able to reproduce and things like that. So chronic toxicity per our state's regulation is 395 milligrams per liter of chloride to 756 milligrams of chloride per liter for 4 consecutive days. The next one is acute toxicity, and this is a single high spike of very high chloride concentration. This spike can result in instant death for fish and other aquatic life within the stream. And acute toxicity is going to be 757 milligrams of chloride per liter or higher from one single event. So that was a very brief recap of chloride and its impacts. So we have a community-based monitoring program here in the Milwaukee River Basin, which we like to call them our hardier volunteers because they're willing to go out after snowstorms and collect data, which is awesome. So our monitoring program began in 2010 with guidance from Water Action Volunteers, or WAVE, and monitors get to pick a location they would like to monitor for that winter road salt monitoring season through a Google My Maps. And then our monitors attend a 2-hour training where they learn protocols and how to calibrate sensors that they'll be using. And this is different than our baseline monitoring program that our monitors do from May to October. This is a trigger event, so after heavy snowfalls or warming events where meltwater is making its way into the stream, monitors are contacted by Riverkeeper staff, and they head into the field to take a specific conductivity reading using a sensor. And conductivity is the measure of the water's ability to hold a charge. So by measuring conductivity, we can estimate the amount of chloride within the stream. So we use the conductivity sensor to clue us in if there's a potential that chloride is exceeding the standards. So monitors are out there, and if they take a conductivity reading that is within a certain range, they'll collect a sample, and we'll ship that sample to the Wisconsin State Lab of Hygiene, and then they will analyze it for the chloride concentration. So the picture here are some monitors learning how to calibrate their sensors. And also all of our collected data is uploaded to the Wisconsin DNR's Surface Water Integrated Monitoring System, or SWIMS, and that goes into an urban road salt study project within SWIMS. In 2020, we had 21 monitors monitoring 33 sites, where we focused in Washington and Izaak counties. So let's take a look at some of the data. This data was collected by Milwaukee Metropolitan Sewage District, or MMSD, and Milwaukee Riverkeeper from 2002 through 2019. For these graphs on the right, you can see that chloride levels are the highest during winter months, which is exactly what we would expect here in Wisconsin and the northern parts of the United States. The top graph is the percent of samples collected that are exceeding chronic standards. So this is the 4 consecutive days of an increased chloride in the environment. And you can see here that March happens to be the highest, with about 4.5% of all samples exceeding the chronic standard. The bottom graph shows acute exceedances. So again, this is that high spike within the stream, and this can just be a one-time event to be considered acute. We can see here that the winter months are the highest likelihood to have acute exceedances as well. And acute exceedances were in higher frequency throughout the winter, more frequent than the chronic exceedances. And here the highest month is February, and this is the data from 2002 to 2019, where about 16.76 of the samples collected were above the acute standard in February. So this flow chart here in the center reflects in a very basic way the flow of the Clean Water Act. So water quality standards are set in place. If water quality is exceeding those standards, segments can be listed as impaired. So things can be listed as impaired for total suspended solids or phosphorus, or in this case, we're focusing on chloride. Once a waterway is listed as impaired, a TMDL, or total maximum daily load, is created as a type of strategy or budget to reduce the contaminant in order to not exceed that standard. So here we just like to highlight in red there that our monitors are playing a critical role in identifying waterways that are reaching toxic levels and are exceeding the standard. So they can go on to the next steps of impairment and then a TMDL to hopefully reduce the contamination in the river. So it's also important to note that the sewage district in Milwaukee does extensive monitoring and data collection in their service area, which is a large chunk of the lower half of the Milwaukee River Basin. So that leaves a lot of data gaps in the northern half of the basin during the winter months. So with that being said, Milwaukee Riverkeeper in the past two years have been beginning to monitor outside of the sewage district service area and out of the densely urban area of Milwaukee, where we know there's a lot of impermeable surfaces, so more salt is making its way into the river. But we're trying to see what's happening in the non-urban areas and seeing if they are facing the same threats from chloride. So we've highlighted the issues associated with road salt's key ingredient chloride making its way into our waterways, and now I'm going to kind of transition a little bit to talk about some preventative measures from stopping chloride making its way into the river in the first place. Since 2017, Milwaukee Riverkeeper has hosted an annual snow and ice control workshop for winter maintenance professionals. So these are the people that are just determining application rates, when to apply road salt, who are driving the trucks. So yeah, we invite them in for an annual workshop. And also the workshop is led by environmental consulting company Walton Consulting out of Minnesota. And historically, we've hosted one workshop per year that focuses on salt application on parking lots and sidewalks. However, due to increased interest in 2019, we were able to host 2 workshops, one focusing on parking lots and sidewalks, and the other one focusing on application on roads and highways and things like that. So these workshops have been a success year after year, and many attendees are interested in learning about how proper road salt application can promote public safety, but also save organizations and cities and villages and private contractors money, while also keeping our rivers healthy. This past year in 2019, we hosted our workshop in the fall, and we had 62 attendees between the two workshops and reached 28 different groups from cities, villages, universities, public school districts, and also private contractors. And in 2020, we'll be hosting 2 workshops again, so we're pretty excited about that. So a little bit more about the workshop. This day-long workshop goes over 4 main topics: de-icing, anti-icing, application rates, and calibrating. And the consultants from Walton Consulting are really great because they're able to dive into the specifics and give the technical tips and tricks to individuals that are actually doing this work in applying the road salt. So I'm just going to touch on each one of these real quick. So de-icing is the traditional way to apply road salt. So this is after the snow and ice have bonded together to the pavement, and the application of road salt works to break that bond. Anti-icing is a more proactive approach. It's trying to prevent the bond from even forming between the ice and the pavement. So to do this, a brine or saltwater mixture is applied to the surface to prevent the bond before the snow event. So the bottom left-hand corner picture, you can see those are anti-icing lines on the road. And then following the snowstorm or during it, snow plows will mechanically remove the snow with their blade on their plow. Application rates are also an important topic talked about at this workshop. There are different application rates for specific surface temperatures, application types, and a bunch of other different parameters. So attendees are given different scenarios and asked to calculate the amount of road salt to be applied. And these scenarios show how much salt can be saved, and that also, I think a lot of people at the workshop equate that to dollars saved as well, which can be really drastic at times. And then lastly is the importance of calibration. So just like our monitors heading into the field, people driving trucks need to be calibrating their spreaders as well. The picture in the bottom right here is a picture from the city of Cudahy. The city is really progressive with their road salt application. They're outside of our basin, but I think the picture is a really great example. So the picture shows the difference of when you calibrate and in your accuracies of application rates if you don't calibrate. So the pile on the left is the amount being applied before calibration, and the pile on the right is post-calibration. And the pile on the right is how much they thought they were applying pre-calibration. I know it's a little confusing, but it just shows the importance of calibration and knowing exactly how much road salt you are actually applying. So overall, we had great attendance for these workshops, and we're excited to continue to promote them and recruit people to come and attend them. We know that the transition to a more salt-conservative application can be hard because there's a lot of different inputs between, different barriers of change from the public or people just not trusting this new road salt philosophy who have been doing it a certain way for so long. So we just hope that the attendees leave with some new bits of information and try to implement some of the protocols and test them out and see if they see any changes. All right, so just to wrap it up here, so large-scale road salt applicators can have a large impact to prevent chloride from entering our waterways, but we also want to promote that individuals can make an impact as well. So Milwaukee Riverkeeper has been ramping up our public outreach to let people know how to adjust their own snow maintenance at their homes and the impacts it can have. So we always promote shovel early and often, using a 12-ounce cup for 10 sidewalk squares, sharing information with your neighbors and friends. And then we're always looking to recruit more road salt monitors to identify where chloride is exceeding the standard. So we do a lot of tabling and outreach. However, in the future, we'd like to do a lot more of that and work with organizations who have attended our workshops and with their groups to see if we can disperse some information as they're trying new methods. And then also kind of targeting areas that from our monitoring we know are frequently exceeding chloride standards. And this is one of our monitors here, also tabling. So we get excited when our monitors want to, talk to the public too. So that's my presentation. Milwaukee Riverkeeper would like to thank Fund for Lake Michigan for funding our monitoring and also funding our annual snow and ice control workshop. And then I can take any questions if we have time. Otherwise, that's my email and people can feel free to reach out.
Yeah, we have about like 9 minutes for questions. But thank you, Katie. That was awesome. The first question we have is, how are you promoting the workshops and what are your numbers for attendance?
For our snow and ice control workshops, we promote a lot online. I have a whole database of people that I reach out to, from the private sector, but then also we reach out to all the counties and cities and villages and universities, encouraging them to attend. So that's kind of how we do that. We try to make sure that people that are just focused on like their residents and shoveling their own driveway don't attend the workshop because it gets very technical. So it's more geared towards those like larger scale applicators. And then as far as, we usually have like 60 people. We had 68 people for our 2 workshops this year. So like 30 for each.
Okay. And then another question, some private winter maintenance companies apply more salt more often than is needed in response to customer demand, like business and property managers that don't want to be sued for a slip and fall on their property. Have the professionals in the workshops commented about pressure from customers to apply more than they think is necessary?
Yeah, definitely. So they definitely spend time talking about how they, they don't want to be liable. So the Fortin Consulting does a really good job of tackling that. And I think the state of Minnesota is working on something around liability, and I'm not sure if the state of Wisconsin is, but it's definitely a concern. And that kind of puts the applicators in a tricky spot.
And then in the training workshops, do you cover any alternatives to salt that can be used for de-icing?
We do kind of, but we really think that salt's the best option and that proper application of salt is the way to go. Some places use sand or things like that, but that's going to make its way into the river as well. And, total suspended solids. So those particles in the water are also a reason to impair a river. So, it's like the lesser of all the evils, and the proper application and application rates can really work well for public safety while also like not making their way into the river.
Then we had a question about, are road salt monitors a part of the program such as WAVE, or is this part of a separate program? I'm not sure if that's for any of the presenters we had today.
So, well, I can talk for Milwaukee Riverkeeper. I feel like WAVE's an umbrella program for our program. So road salt monitors will do everything in the Milwaukee Basin through us, but we work closely with Alana and Peggy for that stuff too from WAVE.
And then can you talk about efforts in the Milwaukee area with SEWRPC and MMSD to help reduce salt use in the region? Is this data being used to help strategize solutions?
That I don't really know. I know like all of our data goes to the SWIMS database, which is the DNR database, and those different organizations can pull that data.
And then do ice snow removal applicators need a license and education credits like PARP?
I don't really know all that about the actual applicator. I know when you attend the workshop, you get a certificate for best practices in snow and ice control. But as far as like the individuals applying, I don't know what they all need.
And then we had Minnesota tried again for limited liability this legislative session, but not sure if it gained traction in light of COVID-19. A group called Stop Oversalting has been leading the charge. It looks like that's just a comment. But I guess at this point, I'd open it up for anyone to ask questions for any of the presenters if you have anything else that you would like to ask. Since we have about 4 more minutes in the session here. And we have a question. I'm curious as to the difference between the 2 monitoring programs. Do you know which of the 2 you were asking about, Debbie? I mean, like Zach and Katie's? Yes. All right. The difference between both programs, between Zach and Katie. So what's the difference between those 2?
I can chime in from the Izaak Walton League perspective. So we use these Hawk field testing strips, which measure chloride. I saw that Katie's volunteers use conductivity meters, just different ways to measure something. Kind of the same thing or similar thing. Ours are, they range from 30 to 600 parts per million. And they're field tests and done by citizens that don't necessarily have any training. So I'd say it's not really as reliable for, you know, any kind of decision making, mostly just an education advocacy program. Also, our Salt Watch program is a national program, so we don't get it quite as involved with some of the local advocacy and stuff that Katie was saying Milwaukee Riverkeeper does.
Thanks, Zach. All right, any other questions? Sounds good. All right, well, thank you, Zach, Linnea, and Katie for the great presentations. We're heading into the lunch break, so please make sure to take a moment to step away from your screen, take a walk or stretch in order to prepare for more sessions this afternoon. The concurrent session 3 starts at 1:45 p.m. And I will post a link to the, oh, Paul already did it. He'll, so follow that link to the next session on the virtual agenda page before you leave for lunch.